Hello, everyone. Um, Sorry, there was a bit of a feedback on my headphones because my audio came on at the same time when I have a YouTube channel open up beside me. So, welcome this evening to everyone to PyLadies Dublin and to August already. I can't believe it's August, and we have two amazing speakers with us this evening. My name is Vicky. I am your host this evening, and I will start off with announcements before I'll bring in our first speaker, who is Doreen Sacker, calling all the way from Berlin, followed by Glenn Strong, who is based here in Dublin. So let's get cracking with yes, who the rest of our team is. So we the rest of the team is Lay and Mick. Both of them couldn't join us this evening, but normally they're there in the background helping me moderate, helping me with tech issues. If things go wrong, they're there to support, as well as helping me find speakers, source venues. Both so they've been immense help, and also bringing ideas as well. So if anyone wants to join PyLadies Dublin team, drop us an email at dublin@pyladies.com. Bring your ideas if you think there's something that you want to try out, and yes, why not? What can go wrong? It's fine. It's good to experiment. And if you want to help, bit more exposure, being part of what's like to be part of the community, and things like other and connecting with, you know, other community organizations and other companies, and also speaking in public. Just let us know. A huge thanks to our community partners, of course, to the PSF. Without them, we don't, they're looking after Python, and they also help look after Meetup for us as well, Meetup fees. And for Coding Grace, we're using Streamyard this evening to stream our talks to you live on YouTube. And of course, to PyLadies. Without PyLadies, we don't have PyLadies Dublin. And there's a huge PyLadies community out there. There's a Slack group, so if you do a search for PyLadies on Slack, you can actually self-join the PyLadies global Slack group. There's a Europe channel there, and there's jobs, and you can talk to organizers and people from all over around the world. A couple of diversity in tech events from around Ireland. So since we're near the kind of middle of August, still a bit quiet. So there's the Women Who Code Belfast breakfast online meetup on August 25th, and then Women in AI practice showcase on August 31st. I update the Irish Diversity in Tech. There's a link below that highlighting yellow. I update that website quite often, and we do have there's a number of September events as well, and then there's conferences as well as tech events from all around Ireland. So if you want to contribute to that, feel free. You can put in a pull request or just email me, and I will add it to it, and you will be credited and everything like that. And speaking of conferences, our friends at Shipicon has are running a conference on Friday, September 2nd, and they've asked me to pass on this link, the community live stream link, for those who can't make it their in-person conference, which will be held at the Round Room in Dublin, and it is also be live stream as well. So because of that, they wanted to be making more accessible for people who can't afford to buy tickets to either come along or attend online. So if you can support it's a wholly volunteer run conference. If you can, buy tickets. If you cannot, do check out the community live stream, and I will send on these slides and to everyone after the this evening's event. And if there's any diversity or other Python events for next month, let me know. I'll add it to our announcements for our next meetup. And you can email it at dublin@pyladies.com, or you can ping it to me on Twitter or Instagram. So just at PyLadiesDub, and I'll see your event and I'll pop it on to our announcements. There's a couple of call for proposals. We have PyData Global, and their conference is at the beginning of December. It's online, so that if you're interested in speaking, their deadline is on Monday, September 12th. So you can find all the information at the pydata.org/global 2022 link there. And PyCon Ireland is back in November 12th to 13th, and it's going to be in person at the Radisson Blu Hotel here in Dublin. And the deadline for the call for proposals is at the end of this month on August 29th. Go to python.ie for more information. Our next meetup will be in person, hopefully. Details are being finalized right now. We do have our first speaker. We have Andressa, who will be talking about the Python GIL, and we have a second speaker, and we're receiving information about that second speaker. So I will update our meetup page, and it will be held at Microsoft headquarters out in Sandyford. But again, we're finalizing details, and everything will be updated on the event page, and I will shout out about it everywhere on social media. So keep an eye on that space. It's going to be on Monday, September 26th. So so it's kind of a breakaway from our usual third Tuesdays of each month. So mark that on your calendar, Monday, September 26th. And of course, do subscribe to our channel. Thanks to everyone who has so far, because we have passed 100. That means we had a nice URL for our YouTube channel. So thank you so much. And follow us on all our social media as well. And if you can give us a hand with social media, that'd be great, because I'm very bad at Instagram at the moment. So any help, again, if there's anyone who wants to volunteer and help us with comms, that'd be amazing. So on our agenda today, we have a couple of speakers. We are ahead of schedule, which is fantastic. So it gives a bit more time for a Q&A afterwards. We have Doreen Sacker, who's calling, I hope I'm pronouncing your name right, who's calling all the way from Berlin. He'll be talking about reproducible machine learning projects with DVC and Poetry. And after Doreen, we will have Glenn Strong from Dublin, who'll be talking about bridging Scratch to Python with Pytch. And after that, we'll have a Q&A after both talks, and then we'll wrap at 7:30. So what I'll do is I'm just going to set up Doreen here, and I'll leave the floor to Doreen. So give me a second. Hi, Doreen.
Thanks so much for the introduction.
Okay.
Thank you so much. All right. Thanks for having me here. And I want to tell you a bit about reproducible machine learning with DVC and Poetry that I quite learned to love. So first about me, I'm a senior data scientist at a company called Opinory. We integrate polls in news articles. So as you can see here, a quick demo, there's a news article, and then we automatically integrate polls there. And my main job is to match the poll with the article to see that it's a matching topic. But don't want to tell you about my job. I want to tell you about my worst nightmare. It looks like this. So if you've worked with Python before, you kind of maybe know this. You have different Python versions on your computer, and you have different versions of your packages, and nothing really matches, and you have so many conflicts, and you don't know what's going on, and then you installed Conda, and then you installed Python with Homebrew, and everything is a bit of a mess, and you don't really know what to do, and you can't update any dependencies anymore. Everything's broken, you have weird errors, and it's not really that easy. And so my motivation for this talk is we've run 4 services, including machine learning models in production. And the models were originally not developed by us. So they were developed by someone else, and they needed updating because one of them wasn't really doing so well anymore. So we needed to do something about it. And it was impossible for us to build on the work of our colleagues because there was absolutely no documentation. We had no idea what training data was, and we had no idea which requirements the model was trained with. And on top of that, it was trained in a Jupyter notebook with no documentation, nothing. So everything was very, very much of a mess. So my motivation is short. I want to have reproducibility of machine learning projects. So colleague A can run something, and then colleague B can reproduce that very easily. All right. 2 things we use for that in our new project. The first one I want to tell you about is Poetry. What is Poetry? Poetry is a Python packaging and dependency management tool. It comes with virtual environment management, and it comes with a dependency resolver. And I'll tell you a bit more about the dependency resolver, because that's the actual really, really nice thing. So you have your app, and then you have a very picky project that you installed, and then you have another project, like a pinning project installed, and both of these libraries depend on the requests library. And as you can see here below, one wants it to be exactly 2.5.2, and the other one wants it to be 2.5.3. So obviously this is not going to match. You can't have 2 of them. So what are you going to do? So that's what the dependency resolver is for. So if you have conflicts and conflicts everywhere, you need someone to resolve it. And that's what Poetry does. And then I'll show you in a bit more basics and like a bit demo kind of way on how to use it. All right. When you're using Poetry, this is what your project structure kind of looks like. So you have a PyProject YAML file, which we'll look at in more detail. Same with the poetry.log file. And then you might have a README, probably have a README. And then you have a source folder and a test folder, maybe. All right, if we look closer in the PyProject YAML file, here you can see you have a specified Python version. So I want my project to run with this version specifically, and I don't want to have any other version, so I want this version to be fixed. And then I want to install a pandas version, or I want to run it with a pandas version, and I want to run it with DVC, which I will tell you more about later. All right, I'll show you a quick demo of how this will look like. So you open your terminal, and then you, like you would do pip install pandas, you do poetry add pandas, and then it will resolve its dependencies, see if it matches with anything else, and then it will install the sub-dependencies. Here we'll install NumPy and Pytch, and then we'll install pandas. And now we can look at the PyProject YAML file, see that's all in there with a description and everything. And now we come to the log file. So what is the log file for? 1 second. Okay, here we go. This is the log file. And the log file is what makes it reproducible. So we installed pandas with a specific version. It has a description, and it says, okay, I need this Python version to run on. And then it says, oh, and I have sub-dependencies, and they're like this. So NumPy has to run in 1.21.0 if now or above. So it says, with this little arrow, I can also have stuff above it. And now, if I install a different package, which also needs a NumPy version, that is, for example, 1.22.0 and needs to be higher than that, then automatically Poetry will update the underlying NumPy version to be 1.22, because it will fit this requirement and it will fit the new requirement we have. I hope this wasn't too confusing. And then once you have all your packages defined in this log file, then you can run Poetry install. And you also specified your Python version. And since Poetry has its own virtual environment management, it will create an environment, and then it will install all the dependencies you've defined in your log file. And they will be always the same. And if you commit this log file, and then it will be the same for everyone. So it's very reproducible, and you don't have as much of a mess, hopefully. All right, how you can use Poetry. You can either set up a new project if you do Poetry, new Poetry demo, or you do Poetry init. And then how to use the virtual environment. You can just do Poetry, run Python and your script, and it will run it in the environment. It created automatically. Or if you're used to using environments, you can do Poetry shell, and then it's like activating your environment, and then you can just do Python script.py. All right, I have a quick overview of the different toolings you can use and kind of their comparison. I know people like different things. So if you want all of these things, you have PyPenv and Poetry. People use both and are really happy with it. I'm now more experienced with Poetry and kind of really like it. I heard that it's most of the time faster than PyPenv, but there are also different opinions about this. But if you want to try Poetry, I can really highly recommend this. All right. Now, the second part, DVC. So what is DVC? DVC stands for Data Version Control. So it's a data and machine learning management tool. And DVC is run alongside Git. Just to clarify, Git is something where you store and version your code. And DVC is something where you store and version data and your model files. So when you can store everything in one place, it makes it easier to collaborate, and it also makes it reproducible. All right, also here, some of the basics. I also have like a quick overview of the project structure, how it will look like. You will have a .dvc file where you also have your cache. Then you can have a data folder. You can have a folder for your plots. You can have a folder for your metrics and for your models. And I personally like to have a folder for your notebooks. This is no requirement by DVC. I just personally really like this because it keeps everything ordered, and everyone like sometimes works with notebooks. So I think that's fine. And then here you already see you have a git ignore and a DVC ignore file. And then you have a DVC YAML file, which we will get to, and a DVC log file, and a file for your parameters. All right, so this is the basic structure, but let's look at it in more detail. So we said it's a version control for your data and your machine learning models. So how does that look like? We run it alongside Git. So your project needs to be a Git project. And then you do git init, as you've maybe done before, initialize Git and set it up, and you do DVC init. What you need to do with the DVC init, you also need to give it like a remote storage. So in git init, you do the same. You tell it where you want to store your code. And in DVC, you also do it where you want to say, okay, for example, I'm using a GCS bucket, like a Google bucket here. And this is my bucket. And can you please use that as your remote storage? All right. Then let's say I have a file. The file is in my data folder, and it's a CSV file. So I do DVC, add, and then my file. What happens next is that a second file is being created by DVC, like a reference file. So this will be a reference to this file and where it will be stored. And then this file you can add to Git, and this file you always add to DVC. And what also happens is you have a git ignore in your data file now, because you don't want this file to be in Git anymore. And then you can say, okay, I'm gonna add my data, and I'm not gonna push it to Git, I'm gonna push it to DVC. So it's gonna be stored in DVC, and only the reference file will be stored in Git. And then I can also do git push like you used to. And if I want to get my data, I do first do git pull to get the reference file, where it tells you, okay, here there seems to be a data file that you want to download, and this is the reference, and this is where it lies in the remote storage. And with this file, DVC can go ahead and say, okay, I have this reference file, it points to my remote storage on Google, and I'm now going to download it. All right, I also have a quick demo here, and hopefully this will make it a bit clearer. Let's see. All right, so you have a Poetry project here, so we can open our virtual environment, and then we can look into the data folder. Okay, we have a CSV file here, as we had before, and we're going to add it to DVC. And now you can see that in your data folder, you now have two files. So here you have your reference file where it's connected to the data file, but it doesn't actually have any data in it. It's very small. And now you can add your git ignore that was created and the DVC file to git, and then that's where you want to commit to git. All right, so we added files to our repository, and we're going to tell that in the commit message. And then we're going to say DVC push, and as you can see here, it will upload or push the file to the remote storage we defined. And the next and only thing we need to do is we need to push the reference files to Git. And now our reference file is pushed to Git, and everybody can download it, or your colleagues can download it from the remote storage. Another thing you can do with DVC, which I quite like, and that is quite useful, are machine learning pipelines. So in the beginning, I told you that we had notebooks where like everything was run and it was kind of messy and you didn't know which steps executed in which order. All right, if you want to know what is executed in which order, you can use machine learning pipelines of DVC. So you first want to pre-process your data, then you want to train it, and then you want to evaluate it maybe. All right, how does it look like? You have this dvc.yaml file that we already saw in the beginning, and there you can define stages. So your first stage is going to be the pre-process stage, and afterwards you're going to have a training stage. And in each stage, you can execute a command. So you can say, okay, in my pre-process stage, I'm going to have the command Python and then run the preprocess.py file, please. And in my training, I want to run the train file, obviously. And then, now it gets a bit more interesting. The preprocess file depends on a data set. But, and then it will output the labeled data set. And now the training stage depends on the labeled data set. So DVC automatically knows, okay, I can't run this stage before I run this stage because I depend on the output that was created here. And then I can run the training and have my model output, I think is the word. All right. To run all these steps in order, you just have to do DVC repro. So it's also quite nice. What happens is you run the DVC repro is you run all the stages. So it says running stage preprocess, and then it will also show you the command that it's running, and afterwards it will run the training stage. If you now go ahead and only change things in the training stage, you potentially don't want to rerun the preprocess stage because maybe you've done like a bunch of pre-processing, you calculated a lot of things and then you stored them. So running them again will take a lot of time. What DVC does is if it knows your code hasn't changed and your data hasn't changed, then you can just skip this stage and it will have the results all cached, which I find very convenient, and it makes the process of iterating also quite nice. All right, the next thing we can do with DVC is the experiment tracking. If you want to run different experiments, so let's say you want to test out different models. So let's say here you have a training model like a linear SVM. Not important if you don't know what these models are, doesn't matter, different kinds of algorithms, whatever. You can also use different data sets, and then you can say, okay, DVC experiment run. And then I can say, okay, I have these parameters and I want you to test different things. And then if I do experiment show, it will also show all the experiments I've run with the accuracy, with the recall. So I think that's quite handy and makes your experiments also quite visible and nicely trackable. So 5 key takeaways from my talk on reproducibility in machine learning. First of all, poetry helps with the Python dependency nightmare. So if you've ever experienced conflicting packages in Python, and if you ever had a really weird error, you will think that this might be very valuable. And poetry makes sure that everybody has the same packages installed. I also find that very very cool, because then it's not like, oh, it works on my machine. And Docker helps a lot with that, definitely. But for machine learning, it's not always very convenient. So in this case, Poetry makes sure that, first of all the requirements are documented. So you have a file where everything's in there that should be installed, that you need. You can easily run it. Everybody knows what to do. So I think that's one really important takeaway for me. And then DVC, it stores your files and makes them accessible to others. So you don't have to send around buckets, and you don't need to tell them, or now I've trained it with this file, and now I've trained it with this file. You can just have it in your project and say, okay, my file is like this, and if I update it, then it's going to be a different file, and the other one just has to run DVC pull, and it's all easy and simple, and the other person will get the file too and work on that. Also, DVC makes sure that all the steps are run in order. So you don't have any notebooks that you have to run in a weird order, or you have one notebook that's pre-processed, and then you have a pre-process version 1 and version 2, and you don't know what to do. So everything is in code, and everything is quite clear. Also makes it nicer for code reviews, I think. And DVC makes sure all the results are stored and accessible. All right, thank you very much for listening to me. And if you have any questions, feel free to add them to the comment section, and then we'll answer them after the second talk. Thanks so much.
Thank you, Doreen. So I'm gonna bring Glenn on. Glenn, I'm just waiting for the screen to share so I can actually pop it up. But thank you again, Doreen, for that, and we'll talk to you in a bit. So Glenn, hi Glenn.
Hi there. I think I'm sharing some slides.
Yes, I see it now. All right, cool. I will leave
Cool.
this to you, and thank you, Glenn. I'll see you in a bit.
No problem. Thanks very much, and I'll try and keep time. So that was really interesting, I think, and a problem that like anybody who does serious development has to solve. So thanks, Doreen, and I hope I don't bore everyone, because I'm going to talk about something quite different, and I'll try not to give you too much whiplash. So I want to talk about a slightly kind of perhaps less technical on the face of it kind of matter, but it is kind of interesting, I think, to a lot of people. So I'd like to tell you about a research project that I'm working on with some of my colleagues in Trinity College Dublin and TU Dublin, supported by Science Foundation Ireland. You can see the core team there on our title slide. We're building a system to try to help people start learning using Python, and I think that's something that might be of interest to some of you, and certainly your feedback would be of interest to us, and maybe your help. So maybe I'll just try and check in. I don't know if there's a raise hand feature here, but I'm just going to go ahead and assume that at least some of you know about MIT's Scratch environment that's targeted at quite young learners of computing. So you have this environment that helps young people, like kind of 9 to 14, 15, maybe older, get used to coding. That's not the problem we're solving, but it's a starting point for us, right? So what's the problem we are solving? Here's Scratch. If you haven't seen it before, I'll just point out a couple of key features for you. But I think the first thing you'll see here is this is a bright, engaging, kind of fun environment to work in, right? It's welcoming, it's simple, at least on the surface of it, although we'll see in a sec, you can do some pretty sophisticated stuff. You've got graphics, you've got sounds, you've got things called sprites, which are rather like objects in a running Python program, and sprites have scripts, which are collections of code, so they're a bit like methods. Scripts run concurrently in response to events. Okay, you build your program completely in the web browser here by clicking together little blocks of code, which actually they are actually the basic statements of the programming language. So it's not clicking together kind of pre-made high-level things. You have kind of the ability to write really interesting programs here, and you run it right there in the browser. So on one side of the screen, you can see I've highlighted there that you've got a stage area, we call it. That's where your running program lives. You interact with it there. You hit go up there in the bar just above it, and your program runs. Over here, you've got an editing area where you put together the blocks of code that are going to run when you hit start or when events happen on the stage. And it's all really friendly, all really easy to work with. And you can see kind of on the left, there was a list of things to pick from that would let you kind of see what's possible. So if you're very young, you don't need to type. You don't need to remember the full list of things that you can use and so on. You just drag them out of the side there, click them together. Might be a little bit of typing if you want to put some text on the screen, but that's about it, right? And these scripts can do quite a lot. You can join up action blocks like move forward, and one of the little objects on the screen will move about. You can say, you know, play this happy noise or play this musical note, and that will happen. And you have things like repeat those blocks 10 times. You can move and turn a bit and get something that can wander about the stage area. This is all like pretty cool. And as I say, you could do some quite sophisticated stuff. Here's just a little handful of examples that we plucked from the selected projects on the Scratch website. Oh, by the way, there's in the order of tens of millions of Scratch users, so there's lots of projects for us to pick from. This one's a 3D rendering engine. This one's a side-scrolling game where you take that little square guy and you steer across and jump and drop blocks that you can climb up on, and there's unlockable skins and scores and things you can share with your friends. This one's a balloon physics simulator. That little circle you can see in the corner is something you can grab with your mouse like a joystick, and that hot air balloon will glide around with a little simulation of physics. And this user has built a game on top of that in a separate project. And of course, if you're a learner, if you're a kid who's playing with this and you're interested to see what's happening on the main Scratch page, for every one of these projects you see, there's a little button saying show me inside, and you can see all the code and you can just extract it and figure out how to use it in your own project. So you learn from the projects you find there. They're not just showing off. And the projects are full of really kind of diverse, interesting things that people do. It's not all games. It's animations. It's stories and movies and things like that. Here's a shadow puppet theater, gives you instructions on how to cut out a shadow puppet and make a light box and project it. And it has a little editor in there for letting you build your own shadow puppets out of some of the pre-made shapes that are built into Scratch. So, okay, point is, you can quite easily build these things in Scratch, and you can go quite far in the kinds of things you can build, all the way up to, say, that 3D rendering engine or the little physics thing. But you can explore the kind of creative projects that keep people engaged and interested, right? Okay, so that's great. Scratch exists, and it's used a lot. It's used in Irish schools. It's used all around the world. What happens when you've gotten quite good with Scratch? That's where we come in. That's the problem we're interested in, right? So the next thing that often happens is you go to learn Python. Okay, I think that's a good thing. I guess probably a lot of the people I'm talking to here think that's a good thing, that we should learn Python, right? It gives us a lot more maybe expressive power. It gives us a lot more access to a lot more of the world of programming, right? The real world of coding. But this is the problem, okay? The students know how to do all this like amazing stuff in Scratch. Like this project I've put up here is a little quiz game. You can press the buttons and you get sound effects and animations and graphic effects. So it does let you kind of play with things like how to learn how to do if then else and loop and keep a score by modifying variables, but it also does it by making things fun. And when you switch to Python, the sad thing that often happens is we switch to writing sequential text input output programs. Okay, so maybe we know that those are actually potentially very powerful things when you move along in your coding domain and you're doing things like slurping in a huge data set that you're processing from online and producing some interesting results from it. But if where you're at is just trying to write the same kind of program that you are writing in Scratch, but write it in Python, the phrase that has been used to us is, all the color goes out of the rainbow, right? You have to write these text output programs. There's nothing like sprites. There's no graphics or sound. There's no concurrency. So you have to change completely the way you design your program around maybe something like a read process output loop. And this this is all happening just exactly at the same time. Like this is happening to you as a learner, exactly the same time that you have to learn to very carefully type in your code and not make any typos or mistakes or punctuation errors, or not, you have to like not wonder why round brackets, square brackets, curly brackets, and angle brackets are different things that can't be confused for each other. You have to remember what the special words are that you have to use because they're no longer on a list for you to pick from, and so on. So what happens is this is too much of a leap for a lot of people. This is a really recognized problem in the education space. And this is kind of the problem we're hoping to kind of help with. So learners lose interest at this really like crucial stage. And we'd like it if they remained interested. It's super, super important, we think, for people to know coding, and Python is a great language for people to learn this in. But can we make it a little bit easier for them to cross that kind of divide from Scratch over to Python? So we're designing Pytch, which is Python through the lens of Scratch, as a kind of bridge to bring them from the fun, engaging, kind of bright world of Scratch to the world of Python, while retaining all of the things they know and introducing the things they need to know for Python. Okay, so what we'd like to do is let them keep those kind of superpowers for making interesting programs and present instead a way to do that in Python. So I have kind of cherry picked a little bit, right, the presentation of this stuff. I mean, you might be sitting there kind of going, right, hang on, right, there's stuff like Pygame, there's Mu, there's, Codebox, there's all this stuff, and that's true to an extent, right? But if you have worked with those in an educational context, if you're trying to make games or visual arts in Scratch, you'll find that there is a big step to be taken there. Like installing Pygame and writing your program around an event loop is a big step for somebody. So we need to help them along with that, right? So we want to help them learn this kind of event-driven concurrent model and learn text-based programming. So what we've done is we've built this environment, this fully browser-based learning environment, which we're calling Pytch, to try to help them figure out how this works. Here's what it looks like, and that's, don't know how well that'll work in the stream. Okay, I hope. That's a little looping animation of a simple program running in our environment. So the things to look out for here are that we've modeled some of the look and feel of what's happening in Scratch. Okay, so you've got like your start-stop buttons roughly in the same place. You've got a stage where your program plays out, and the sprites, the actors on the stage, move around on that in response to things you do. You've got your coding area over on the other side where you're building some Python code. It's real Python code here, or at least like kind of 90%, 99% real Python. We have had to kind of make some little adjustments, and I'll talk about them in a second, to make it all work properly, right, in this kind of concurrent event-driven model. We're not this isn't something we could run directly on the desktop, at least not right now. I'll just kind of highlight here some of the, actually, I'd like to hear if this is actually useful, because I just drew this earlier today in response to somebody's questions. So you can tell me if it helps. But right, the correspondences here are as strong as we can make them. You've got Scratch on the left here, Pytch on the right. You've got your text area, you've got your code area. What I'm not showing you is we have auto-completion pop-ups for some of the built-in functions and so on to try and reduce the amount of typing people have to do. We've got the list of blocks that you've got in Scratch. We've got the corresponding list of everything we currently support, which is not everything Scratch does. There's 15 years of development behind Scratch, so we're not doing everything they do yet, but we're doing, we think, kind of core, most important stuff that we can identify. And that's all there on the left with their Python correspondences, so that you can click copy and paste or type it all in again to get your real world kind of program going, the idea that you have. We've got start and stop buttons that are similar to Python, and so on. Just to give you an idea for what's happening in our system, here's a little example of Pytch code. This is from the little owl bouncing around the screen project that I shared with you a moment ago. This is, pretty much the full code for the entire program. In fact, I think there's an import at the top. Yeah, that's I think that's it. I think that's the only missing thing. And 2 lines of code to get that backdrop up. But so each actor, each thing that can move and interact on the stage is represented by an object. We have a list variable that's storing the images that are used, and these are all just uploaded into the online environment, so you don't have to fuss about kind of fighting with folders and directories. And we've got some functions, methods of the class, that correspond to things that will happen when you take an action in the program. So, you know, when you press a key or click on something or whatever, we'll run these bits of code. If you're familiar with Scratch, you'll see that we've very sort of deliberately chosen names for the built-in routines, like say for seconds, glide to X, Y, and wait seconds, that match the names that are used on the Scratch blocks. So what we're doing here is saying you have spent some time learning how Scratch lets you express a program, and we're going to let you remember that and keep using it for a while. And the idea is not that you would stay with Pytch for the rest of your programming career or anything, but that this becomes the bridge you cross, and at some point you want to do things you can't do in this environment. You want to do web development, you want to do data science type analysis, but you've, in the process of working through making some interesting things in Pytch, learned enough Python that it's no longer one huge leap you have to make. So a couple of things I'll flag here. We're using, as you can see there, we're using Python decorators as an analogy with the hat blocks that you would use in Scratch. So if you're not familiar with Scratch, you build these stacks of blocks and click them into blocks that say, when you click on this, or when this key is pressed, or whatever. So as an analogy for that, we're using these decorators. And of course, it's not necessary for somebody to understand a moderately advanced topic like decorators in Python before they can make use of them. So we present this just as a piece of syntax and say, well, you know, you're used to hat blocks. Well, the hat block equivalent in Pytch is at Pytch and some instruction. And we're always trying to be very clear as to when it's Python, something that you can take with you across the bridge to the next thing, and Pytch, when it's something that is about this kind of transitional learning. If you're watching real carefully, nobody's mentioned this in the chat yet, so I'm just going to point out there's kind of a really weird structure to that move around function. I mean, if you're used to writing functions in Python, you're looking at that and going, oh, because what I have there, of course, is a loop with a condition that will never be false. And this is where we've had to make a little change to the way we present Python. So we're trying to model the quite pervasive use of concurrency that Scratch has, where you can write lots of independent bits of your program and not worry too much about interleaving the execution, right? So we're trying to take what you've learned about how to structure a program in Scratch and that you keep it for a while as you cross this bridge. And that means that we've had to enable concurrency in our in-browser implementation of Python. So that infinite loop that says glide around the stage, then wait, glide to a place, a random place, wait a second, then glide to somewhere else and glide to somewhere else, that runs forever. But all the other blocks of code that are running in response to events are also running interleaved with this. So fine. And I think I've already shown a little bit of this UI, but I'll just show kind of another couple of quick bits. This is what it looks like when you pop open a little side panel with some help. That's the full code for the program, so you can see, right? There was an import and there was one more thing. Okay, so that's our idea, right? We're working on some simpler UI ideas to help reduce the amount of boilerplate code, and we have some ideas for how learners can move from Pytch into real-world Python in web or data science, and we have some development done on those too. That might be something where we'd love to hear more from people who are kind of out on the coalface of industry, as it were, doing this. We have a bunch of built-in learning resources and tutorials, self-directed stuff, and self-paced follow-along tutorials that take you step by step through building programs and introduce concepts in looping, function definition, you know, string indexing, all kinds of things you might want to do, and we have plans for lots more. We have some physical computing things that we're working on. We have a proof of concept implementation working now on the Raspberry Pi that lets you plug things into the GPIO pins on the Pi, and you find me a person who doesn't like flashing lights in their program and big blinking things that are connected up to the computer. And That's got to be fun, right? Switches you can close and open to cause effects to happen in the program. So we'll do the questions at the end, but I see them coming in the chat. So yeah, so we're building this on a bunch of open source projects that sit underneath us, of course, and credit needs to be given to the Sculpt engine, which is an in-browser Python implementation, to the ACE text editor we're using, and a bunch of other components we're working with. What we have at the moment is a system up and running. We have evaluation happening in various venues, some schools, some dojos, some private coding academy companies, and some others. And we're getting good positive feedback, and we're also updating the system in response to the feedback we're getting. We're mostly thinking here of school students aged 12 to 17, and a lot of our testing work has happened at transition year, which, if you're not familiar with Irish second level education, that means about 14 or 15 years old. Computer science isn't really a subject in second level in Ireland until that point. So these tend to be people who've done a little bit of Scratch, maybe in some informal classes or after school clubs or things. So they're just ready to make that transition. We have used it with kids as young as 9, if they have some experience. And what we'd love is for more people to try Pytch out with their students or their kids or someone, and give us feedback. We'd love to learn from educators about what would make the classroom experience smoother. We have ideas for auto grading and things like that. And we'd love to talk to people who'd fund or sponsor further development. At the moment, we're funded by Science Foundation Ireland on a grant for this year. We're hoping to secure more funding to continue this work, because we think this is actually a really, really useful thing for people trying to teach Python to kids who've already been exposed to this very standard intro language, Scratch. So we've got all this big list of stuff that we want to do next, right? Better ways to get the program in, reduce the amount of text and typing, give better supports in the editor for that, structured editors, if you've seen things like frame-based editors, or things that can hide some of the boilerplate stuff like the classes for a little while, until we can progressively disclose them to the user as they need them and focus in on the core things, and add more multimedia and physical computing features. And we'll be at Science Week this year and Code Week doing some demos with those and doing a public launch. But yeah, okay, there we go. Thank you. Here's how to contact us, and also, of course, right, through Vicky. She knows how to track me down. And yeah, okay, try it out. It's live, it's online, it's free. Sorry, I think that's obvious. I hope it's all free. And if you're a puzzle solver, work out what this program is doing. It's a little computer sciencey algorithm. So you can work out what it does just from watching the animation. Okay. How am I doing for time? I think I'm done.
You're doing grand, Glenn. Thank you for that. I'm really, really excited. I was trying not to give kind of spoilers, because I saw the electronics with your colleague Ben. Anyway, I'm going to bring in Doreen in here as well. I'm going to just leave your animation going so people can actually just have a look. So thank you, Glenn, and thank you, Doreen, for your talks. So anyone have any questions? Now, there's while I'm talking to you right now in real time, there's a few seconds delay from YouTube as well. So I'm gonna give people a chance to see if they have any questions for either of you. I think let me see. I think there was one for Glenn you mentioned there as you were talking. It says because this is browser based, is there JavaScript under the hood?
Short answer, yes. Long answer is yes. So we're using Sculpt, which is a transpiler from Python to JavaScript. It supports almost all of Python. I think there's a couple of very sort of dark corners that aren't, especially to do with introspection, that aren't fully supported yet, but it's a pretty complete Python 3. There's 3 or 4 different implementations of Python in the browser that we kind of evaluated and looked at. We went with Sculpt just because it fit our concurrency model quite well. It was easy to incorporate that. But yeah, so you can only currently run this in our online system. We have ideas for desktop Python, but it's a lot of work, and I don't think we can, we can't commit to any development there.
Right. So anyone have any questions for either speakers? Not even questions, I think even just like share your experiences as well. This is the part where it gets kind of a bit quiet. Everyone gets a bit shy.
That's great.
I notice we have people from all over, which is great. Quite international viewership this evening. Um, but yeah, as I was saying more, mentioned that I was really excited when I saw Glenn's colleague. He actually showed me. It was one of our calls. Just a cat kind of about how they're doing in Pytch, and there was he was showing me all the blinkies and stuff. I got so excited because I'm kind of sort of a little bit of a maker hat on me as well. So, and at the time this was before prior to EuroPython, and so it was great to um, see all this, especially happening in Ireland, because a lot of the stuff tend to be coming from the US, and here are all the technologies, and it's great to see this happening right here, and like I suppose my question for Glenn is like, how do you want people to be involved with Pytch? I know you kind of mentioned that briefly there. Um,
I really briefly, right? Help. We need I think two kinds of help, really, right? It's all well and good for us to try to figure out what people need from this, right? To evaluate it, and our intuition and also our like extensive kind of reading on the subject has guided the development here. This is an academic research project out of Trinity College, so we're quite keen to make sure that we have as much of a broad base of users as we can. If you have a context you think you could use this in, we would love to hear from you. That might be like a coding club you're involved in. It might be a school you're involved in that's teaching CS. If you think they're interested in the question of how to make it a little easier, a little more fun, we'd love to get involved. We have some experience doing this now, and we have lessons that can be tried out and so on, and we have ways to gather data that help feed us in. So that's one thing. The other is if you think this is like a worthy project, if you think this is an interesting thing, we'd love to kind of expand the team and have more people assist us with design development and so forth, right? So basically we're open to collaboration and communication about anything really. So examples of places that we're planning to use this that aren't schools soon. Vicky, as you were talking about maker stuff, so we were talking to Dublin Maker and
which just happened recently, by the way. It's
So
about Dublin Maker. If people heard of Maker Fairs, this is the Irish version. It's the annual Maker Festival. It was the first time back this year, and it's held in a park in a lot of tents, and the sun came out and everything. So there was a lot of demos from like crafters, hackers, educational technology, and so on. Sorry, Glenn.
And Maker Meet is the other group we're working with at the moment, and we're going to be doing some stuff around Science Week in November with them. So we're hoping to kind of do some work in libraries with kids who want to maybe do a little bit more in the way of physical computing stuff there. I think I was just looking there now at the window. Do I have a picture of the blinking lights? I don't have a fantastic picture of it, but yeah, I could share it.
While you're looking, saying the Madeline again, who asked the question earlier, she actually said that Harvard's CS50 course starts with Scratch and then moves on to C.
It does. Yeah. So CS50 uses Scratch in like so CS50, for those who haven't seen it, is kind of first year college basically. It's a computer science course that's taken by I think everyone in certain cohorts in Harvard, even if they're not taking technical subjects as their degree. And they start with Scratch. They begin with this kind of environment you've seen that's, looks kind of kiddie-ish at start, right? But it's actually quite sophisticated. But they also recognize that you have to get sort of beyond the block-based environment if you're going to be able to progress, right? If you're going to try and take things, everybody here knows how much you can do with Python, right? And how many packages there are out there that you can work with. If you can't access them, you'll never be able to do all this other stuff, right? So Doreen, you were talking about working in Jupyter notebooks, right? It's a fantastic way to experiment with data. Imagine how comfortable kids could be later in their school career if they're able to actually do their science projects in a Jupyter notebook, but they need to be able to do some of the coding.
Yeah, absolutely. I think that's so cool. And such like an important project as well.
Imagine hooking that up to kind of hooking it up to experiments and actual physical ones
Mm.
to see and do, and not just the visual aspects of it. It'd be pretty cool. But yeah, if anyone, do you have any questions? Don't be shy. um, but if you don't want to type it out, I can mention also that you can send questions on to me as well, and I'll pass them on to Glenn and Doreen. And the answers, I'll post them in the comments in YouTube, if there's and also on the Meetup event page, as well as I'll send it out to anyone who's RSVP to the Meetup event as well. So don't be shy.
I'm
Clear. We're all friendly people here.
with
Oh,
with your
sorry.
with your permission, I'm gonna just share. Ben, who's my colleague on this, has just reminded me where I can find this.
Yeah,
So that's isn't it exciting? But it's Pong with a controller made from some electronics and a chopping board, I believe, from Ben's kitchen. And
pretty cool.
as you play the game. Oh yeah.
Oh god. Nice.
So we have, so that's an example of the kind of physical computing stuff that you can get to do with kids, and you write it in Python, but they understand it from the background in Scratch, and it works.
Amazing.
Right, we have a few minutes left, but we're okay to wrap up a little bit early because I know you're an hour ahead of us, Doreen, because you're based in Berlin.
Yeah.
And I know some of us probably might want to go and make our dinners and stuff soon. So, if there's no other questions, I'm going to give you a few more seconds while I ramble on. I'd like to thank everyone again for joining us this evening. I would like to thank Glenn and Doreen for your time to give this talk. This video will be up like forever, ever and ever, as long as YouTube is there. As long as they allow our channel to be there, it's going to be there. So if you want a copy of it, let me know and I'll send it on to you as well. And if there's any other kind of announcements or anything you don't have it right now, but you want me to share, say for instance, then you mentioned Science Week, that you'll be there. I can post about that as well because Science Week has a lot of cool stuff for all ages, not just for kids, and it's all free. All those activities. I think there's going to online and in person now as well. For Science Week, is it, or is it mainly all virtual? I'm not quite sure. But in the meantime, yeah, I think that's it. I think everyone is just saying thank you for the talks and a lot of clapping. And thank you again. And I will leave you to have a very nice evening and keep cool. Doreen, I know it's still very hot over there. we have a break over here right now, so I can drink my hot tea. But yeah, so have a great rest of the summer, and hopefully we'll have you back again sometime, or maybe in the future we get to see you if I ever visit Berlin.
Yeah.
And
Like send me a message. That would be nice.
and thanks, Glenn. I know we're gonna definitely cross over because I still have, even though I'm not with Dublin Maker as their maker advocate, I'm still interested in all the kind of makery kind of type stuff, and I like to bring this over to to adults as well who mightn't be programming as much, but this would be a great way to bridge them to coding as well as experiment with physical kind of electronics and things. So thank you, everyone. Thank you this evening, and I hope to see you all soon. And till next month.
And thank you for organizing this. It was a really cool event. Thanks so much.
All right. I'm gonna put in hopefully this video.
Agreed. Thank you.
For the next few seconds. So hopefully I'll see you all. But I'm gonna put this video on before I cut off the broadcast. Okay. Have a good evening, everyone.
Thank you so much. Have a good evening.
Thanks,
Bye-bye.
everyone.